And we come now to the little introduction about the Earth and some things that you probably do know and maybe a few that you don't know here. So we're going to discover some things about the atmosphere and go ahead and take some views of photos from space of the Earth. We definitely notice a change in color compared to the other terrestrial planets. We have liquid water on the Earth, so get this nice blue effect from the water. And we can view the other side of the Earth as well. And we have an atmosphere that's medium thickness, not real thick like Venus, not real thin like Mars. So we'll talk about that as well. Now, the Earth's atmosphere constituents are much different than Venus and Mars, where that is primarily carbon dioxide. Here we find nitrogen and oxygen, and a mixture of some other gases as well, but primarily nitrogen and oxygen. Why do we have this and not carbon dioxide? Well, the Earth does have liquid water, and this liquid water dissolves carbon dioxide and puts carbon dioxide in vicinity of other minerals, and then these combine and form rock, limestone, other rocks that settle out of the oceans and lay down locked in deposits of this carbon dioxide. We also have biologic activity that, as far as we know, does not exist on Venus and Mars. And this plant life and algae action takes in carbon dioxide and releases oxygen. So we have a resupply of oxygen. Our oxygen in our atmosphere would disappear as oxygen will combine with other elements. We need to resupply it, and this plant life enables that to be done. So we have oxygen in our atmosphere. Nitrogen is a gas. So some other elements in the periodic table that are abundant don't form gases. But we have nitrogen, we have oxygen for our atmosphere. We have a protection layer in our upper atmosphere from the oxygen. It forms ozone, where three oxygen atoms link together. And this ozone is effective at absorbing ultraviolet light from the sun. So ozone absorbs the ultraviolet there, protects the lower atmosphere from damage, because that ultraviolet light has enough energy to break apart molecules, to disrupt molecules. Why is it that the ozone layer is above water vapor, the H2O molecules? Well, the H2O molecules, when they rise, the temperature of our atmosphere decreases, and it gets to a place where the water condenses and doesn't rise higher. It forms water structures that are heavier and sink back down. So we are protected from having our water molecules dissociated and then losing hydrogen to outer space. This ozone layer limits the amount of ultraviolet light at the surface. You know, you need to put on sunblock when you're being exposed outside for significant amounts of time. There is still ultraviolet light that comes through the ozone layer, but there'd be much more if the ozone layer was not there. This oxygen in the atmosphere does form what's called a biomarker. And as astronomers seek out evidence of life on planets around other stars, one item that they're looking for is the presence of oxygen in the atmosphere. There could be other reasons that oxygen would be there, but presence of life will produce oxygen in the atmosphere. Now, the atmosphere we have now was not the original atmosphere of the Earth. The scientific hypothesis is that the Earth formed along with the other planets and the Sun, and at that time, hydrogen and helium would be in the atmosphere of the Earth because those are the most abundant elements in the solar system, and they were lost. Why would they be lost from the young Earth? Hydrogen, helium. Well, you might recall that atmospheres are lost if the planet doesn't have enough gravity and it's too warm. So the Earth, in its position from the Sun, had a temperature that enabled the hydrogen and helium to obtain escape velocity. The Earth did not have enough mass to have enough gravity to retain hydrogen and helium. So we lost that atmosphere, and we have a secondary atmosphere. And the sources for the secondary atmosphere would be gases from the interior coming out of volcanic vents, geysers, and other semi-conduits from the interior of the Earth to the outer part of the Earth. Also, comets and asteroids those impacts could deliver molecules to us, the lighter elements and the ices of the comets, and supply us with water and other valuable molecules that we have in our atmosphere today. Is our atmosphere fragile? Would you call it fragile? I think so, as our atmosphere is not very thick. A gas, of course, has no top, but in terms of where most of our atmosphere is, most of it's within about 7 miles of the surface. 7 miles, you can walk that distance in a day. It's not very thick. You can drive it in a few minutes. So we have a thin atmosphere, and where the atmosphere gets noticeably thick for friction with bits of sand coming in that form the meteors, that's around 50 miles altitude. That's still not very thick. So we have a limited resource. Our atmosphere is not infinitely thick. It's relatively thin compared to the size of the Earth. It is true that carbon dioxide levels are rising. We have human impact on our atmosphere from burning fossil fuels and reducing the vegetation that removes carbon dioxide as forests are cleared out. There is a debate on whether humans have the ability to permanently damage the atmosphere or not, but we don't want to push it, I don't think. We want to take care of our atmosphere and pay attention to what changes are occurring and what the human effects are on the atmosphere. There is a good example from the 1900s. The middle of the 1900s, it started to be noticed that the ozone layer was thinning, this layer that protects us from ultraviolet rays. And internationally, there was a movement to restrict the chemicals that damage the ozone layer, found in aerosol cans, hairspray and such. Not today, because those have been restricted. And it is a measurement that the ozone layer is restoring itself. We are getting a thicker ozone layer, and this one human effect has been reversed. Little evidence of population here. The Earth at night, again viewed from space. And where you see more lights, there are more people and more industrial activity and more higher standard of living that can afford to waste energy at night by lighting up the environment. So you can see the United States, Europe and that, some South America entries, Japan, India, China, South Africa. Just a view, another view here of Earth at night, again from space, and seeing major population centers in the United States. So that's where I'm going to stop here with this sort of introduction to the Earth and its atmosphere. You can check out some other videos coming up for other pieces of information. Let's see if I can close this.